Hello everyone, my name's Miss Heaton and I'm here to teach your maths lesson today. Today is the first lesson in a new series of lessons to explore the relationships between fractions, decimals and percentages. So if you've been keeping a journal of your work, you might want to have a look back at your work on fractions and remind yourself of all the key concepts, language and representations that we've used already. You might also want to get yourself a pen and paper ready for some of the work we're going to do. So gather everything you need and I'll see you in a moment. Chosen these representations so we can recap what we already know about fractions and also start to think about what we also know about decimal fractions and the similarities and differences between those. Have a look at these three representations and think about the notation that you would use to represent them. What's their value? How would you express this? Can you pause me now and write down what these diagrams show? And do you think you can find different ways to express your ideas? What did you write down? Did you write that these all show 1/10? Well done. And so what does that mean? It means that the whole has been divided into 10 equal parts. Excellent, which is what's represented by the denominator. And we have one of those parts. Fantastic. And we can see here, can't we, in this top diagram that the whole has been divided into 10 equal parts and each of those parts is 1/10. So that's a little recap on our fractional language. I'd like you to pause me again quickly now and have a look at this number line. Tell me what you notice about it and tell me what you think the value of the blue bar would be. How did you get on? What did you notice about this number line? Did you notice that its value was 1 metre? Really well done. And how did you express the value of the blue bar? Did you say that this was 1/10 again? Fantastic, because the whole has been divided into 10 equal parts and the whole is 1 metre. So 1 has been divided into 10 equal parts and we can see that these divisions are equal and we have 10 equal divisions and 1 metre has been divided into those 10 equal parts. Did anybody write it differently? Did anyone perhaps write 0.1 of a metre? Well done if you did. Perhaps you wrote it both ways. Perhaps you wrote 0.1 of a metre and 1/10 of a metre. Do they mean the same? Yes, they do, don't they? We can read them both as 1/10 of a metre. 0.1 is the decimal notation and 1/10 is fraction notation. So if we look at 0.1 as a decimal, 1/10 of a metre, why do we know it's 1/10? How can you explain to me that that's 1/10? Can you talk to me about the values of the digits? What do you know about the value of these digits? What's the value of the digit 1? It's 1/10, really well done. And why is it 1/10? Because it's in the tenths place, isn't it? So this is the ones place and this is the tenths place. So 0.1 is equivalent to 1/10. They both have the same value. This is decimal notation and this is how we write 1/10 as a fraction. But actually it's really good practice to read them both as 1/10 of a metre. Even though we're expressing 0.1 as a decimal because we're using a measures context. And very often, depending on the context we use, is whether we use decimal notation or fraction notation. We can see, can't we, if this represents 1, then 1/10 is 1/10 of the size of 1 and 1 is 10 times the size of 1/10. Fantastic. I bet you've used this equipment in your schools, haven't you? So this is the base 10 equipment. Some teachers call it Deans. And actually, I'm going to pull some up on the screen now and I want you to tell me what you think their value is. What would you say the value of this is? Did anybody say 100? I heard a few of you shouting 100 then. What about the value of this green rod? Did you say its value was 10? What about this? Did you have the value as 1? Now very often we use this equipment, don't we? I've got some here. Very often we use this equipment to represent 100, 10 and 1. However, just like the number line that we saw on the previous slide, I can have a number line that represents 1. Or I can have a number line that represents 100, from 0 to 100. And in this case, I can assign any value to this equipment. So what if I told you that I'm going to say that the blue block has a value of, you guessed it, 1. So my blue block has a value of 1. Do you think you can tell me what the values of the green rod and the yellow cube are? Pause me now and you can use your finger to trace across the blue block, count how many equal parts the whole 1 has been divided into, and come back and tell me what you think the value of the green rod and the yellow block are. How did you get on? What did you think their values were? I'm going to ask you to prove it as well. But first, can you tell me the value of the green block? Did you say it was 1/10? Fantastic, well done if you did. And what about the yellow cube? Did you say that that was 100th? Fantastic, really well done if you did that. Shall we have a look at how we can prove that? How did you know that the green rod was 1/10? Did you trace it with your finger and see how many of the green rods you could use to cover 1? I did too. Shall we have a look at that together? So 1/10, let's count them together, count with me. 1/10, 2/10, 3 1/10, 4 1/10, 5 1/10, which is 5/10, isn't it? 6 1/10, 7 1/10, 8 1/10, 9 1/10, 10 1/10. And we said, didn't we, that 1 was 10 times the size of 1/10. So it makes sense that we would need 10 1/10 to cover 1. Brilliant. So I think we've proved, haven't we, that the green rod is 1/10 of the size of 1. How did you write it? Did you write 1/10? Yes, because 1 has been divided into 10 equal parts, which is represented by a denominator. So each green rod represents 1/10 of 1. And 1 would be 10 times the size of 1/10, wouldn't it? Did anybody write it as a decimal as well? Well done if you did. So we can express it as a decimal, can't we? And how did we know that this has the same value as 1/10? Because, can you shout it out to me? Because the digit 1 has the value of 1/10 because it's in the tenths place. Fantastic. So these are equivalent. So 1 has been divided into 10 equal parts. Each green rod represents 1/10 of 1, and 1 is 10 times the size of 1/10. How did you decide that the yellow block was 100th? Did you see how many yellow blocks would cover the blue block by tracing with your finger? I did too. Shall we have a quick go together? Do you think you can help me to count? 1 100th, 2 100th, 3 100ths, 4 100ths, 5 100ths, 6 100ths, 7 100ths, 8 100ths, 9 100ths, 10 100ths. Whew, this is taking a while, isn't it? Did you carry on and count how many there would be altogether? How many 100ths would you have found? 100 100ths. Can you tell me anything else that you notice now? Do you notice that 10 100ths is covering the same space, isn't it, as 1/10? Should we check that? Perhaps some of you did that. Perhaps some of you saw how many 100ths would cover 1/10. Count with me. 1 100th, 2 100ths, 3 100ths, 4 100ths. How many do you think we're going to get? Put that in your head and see if you're right. 5 100ths, 6 100ths, 7 100ths, 8 100ths, 9 100ths, 10 100ths. Fantastic, so you were right, weren't you? 10 100ths is the same as 1/10. And so we can scale up by 10, can't we? Because we know 10 tenths was the same as 1. So if I scale 10 hundredths by 10, then I would have 100 hundredths would make 1. Fantastic. So 1 has been divided into 100 equal parts, and each yellow block represents 100th of 1. Really well done. So we can say, can't we, that 1 is 100 times the size of 100th, and 100th is 100th of 1. Fantastic. How did you write 100th? We saw on the previous slide, didn't we, that 1 has been divided into 100 equal parts, and one of those equal parts is 1/100th. But how did you express it? Did you express it as a fraction and write 1/100th? Fantastic if you did, because we know, don't we, that 1 is divided into 100 equal parts, which is expressed by the denominator, and each part is 1/100th of 1, and one of those parts is represented by the numerator. Did anybody write it as a decimal? I hope you did. If you didn't, pause me now and quickly write it as a decimal. What did you write? Did you write this? How do we know that that represents 1/100th? What can you tell me about the value of the digit 1? The digit 1 is in the hundredths place. Yes, we have the ones place, the tenths place, and this is the hundredths place. Really well done. So 100 in fraction notation is equivalent to 0.01 written as a decimal. But as we said with 1/10, actually, it's better if we read that as 1/100th, as it helps us to understand the value of the digits. And we can see, can't we, as well, that 1/100th is 1/100th of 1, and 1 would be 100 times the size of 1/100th. So we can apply those same principles as we applied when we were looking at 1/10 and the value of that. I'd like us to quickly recap what we've already found out so far. So we can write the relationship between 1 and the number of equal parts which it has been divided into with either fraction notation or decimal notation. However, it's really useful to help our understanding if we read both the fraction and the decimal with its name. So we can see here 1/10 written as a fraction and 1/10 written as a decimal. And some of us might say that as 0.1, but actually if we still read it as 1/10, it's much better practice for helping us to understand the value of the digit 1 in the tenths place. And the same with 1/100th. We can write it as a fraction and we can express it as a decimal. And some of us might read that as 0.01, but if we still read it as 1/100th, because that's its value, then it's much easier and it helps us to understand. So although we can express both of these as fractions and decimals, let's get into the habit of reading them with their accurate name of either 1/10 or 1/100th. Can you see 1/10 in this chart? Put your finger where you think 1/10 is in this chart. Have you put it here? Fantastic. I'd like you to help me read all of the other numbers in this first column. And I bet you're thinking, well, that's really easy, Miss Heaton, because it is really easy for us. But I'm going to ask you to read the numbers and then explain why they have the value that they do, and also explain the relationships between them. So I'd like you to pause me now and just have a look at this first column here. Read each of the numbers, have a think about why they have the value that they do, and what is the relationship between each of these numbers in this first column. How did you get on? I bet you found it really easy reading those numbers, didn't you? And I hope you could explain why they had the value that they do. And let's have a think about how to compare them too. So tell me how to read this first number. We read it as 100. Fantastic. How do you know that that is 100? What do you look at to help you make that decision? Do you look at the digit 1? Fantastic. And we can see that the digit 1 is in the hundredths place. So that's why we call it 100. And we have 2 0 placeholders, don't we? Would we read that 100? We wouldn't, would we? And that's why it's really good practice not to do the same with decimals. Can you help me read this number? It's 1000. Fantastic. And why is it 1000? Because the 1 digit is in the thousands place. Fantastic. Can you tell me anything about both of these numbers? A comparison of them. How can you compare them? Do you notice anything about their relative values? Did you notice perhaps that 1000 is 10 times the size of 100? Well done if you did. And so 100 is 1/10 of the size of 1000. Brilliant. Can you help me with another pair? How did you read this one? That's really easy, Miss Heaton. We read it as 1. Why do we know it's 1 though? Because the digit 1 is in the ones place. Excellent. And we don't need any 0 placeholders, do we, when our digit 1 is in the ones place? What about this number? Right, be careful how you read this one now. Let's read it together. It is 1/10. Fantastic. I hope nobody read 0.1 because we're reading it with its value, aren't we? And its value is 1/10. Why is its value 1/10? Because the digit 1 is in the tenths place. Fantastic. So what can you tell me about the values of both these numbers if we compare them? We spoke about this before, didn't we? So if we've got 1/10 and 1, then 1 is 10 times the size of 1/10, and 1/10 is 1/10 of 1, because 10 1/10ths is equivalent to 1. Fantastic. Do you think you could apply that to 0.1? Silly me, what did I do then? I should have read that as 1/10. And so how am I reading 0.01? I should read that as 100. Fantastic. I'd like you to pause me now and decide why I'm reading those like that. How do I know that's their value? And can you compare them in the same way that I compared 1/10 and 1? Can you compare their sizes and their values? How did you get on? Why did we read 0.1 as 1/10? We read it as 1/10 because digit 1 is in the tenths place. Fantastic. And so we read 0.01 as 1/100th because the digit 1 is in the hundredths place. Fantastic. What can you tell me about their comparative sizes? So is 0.01 is 1/10 of the size of 1/10, and 1/10 is 10 times the size of 100th, because 10 100ths has the same value as 1/10. Brilliant. Shall we have a look and see if we can apply that all through this chart then? So if we start again with 1000 and 100, we said, didn't we, that 1000 is 10 times the size of 100. So therefore 100 is 1/10 the size of 1000. And so 1000 is 10 times the size of 100. Fantastic. Can you tell me what this arrow shows? It shows that 10 is 1/10 the size of 100. What's about this arrow? It shows that 100 is 10 times the size of 10. What does this arrow show? It shows that 1 is 1/10 the size of 10. And so therefore 10 is 10 times the size of 1. Let's have a look at these again though. So if I've got 1 and I've got 1/10, what does this arrow show? This arrow shows that 1/10 is 1/10 of the size of 1, because 10 1/10ths is equivalent to 1. And therefore, what does this arrow show? It shows that 1 is 10 times the size of 1/10, because 10 1/10ths would be 1. Fantastic. What about 1/10 and 100th? What can you tell me about the comparisons of those? So 100th is 1/10 of the size of 1/10, because 10 100ths is equivalent to 1/10. And therefore, what does this arrow show? It shows that 1/10 is 10 times the size of 100th. Excellent, really well done. So we can use those comparisons, can't we, to help us understand the values of the digits and how to read those numbers. And actually, these numbers all represent one of a unit. The digit 1 tells us the value of the number depending on its place. So when the digit 1 is in the hundredths place, we get 100. But when the digit 1 is in the hundredths place, we get 100th. Fantastic. Have a look at this bead string. It has a value of 1 as well. And we can see, can't we, we've got 0 and 1. So the bead string is like a number line, and it's been divided into a number of equal parts, and each of these beads represents one of those equal parts. So do you think you could tell me where you would label 1/10 and 100th on this number line? Pause me now and have a think where they would be. How did you get on? Where did you put 1/10? Put your finger where you would put 1/10. Have you got your fingers ready? Did you put 1/10 here? Well done if you did. Why did you put it there? Did you write it as a decimal or a fraction? You could write it as either, can't you? They both mean the same thing. They both mean 1/10. We read them both in the same way. Why did you put it there? We put it there because 1 has been divided into 10 equal parts. Let's check that. 1/10, 2 1/10, 3 1/10, 4 1/10, 5 1/10, 6 1/10, 7 1/10, 8 1/10, 9 1/10, 10 1/10, which is 1. So 1 has been divided into 10 equal parts, and we can express one of those equal parts as 1/10, as either a decimal or a fraction. Well done. Where did you put 100th? Put your finger where 100th would be. Did you put it here? Well done if you did. Fantastic. Why did you put it there? Because 100th represents one of the equal parts, and the whole 1 has been divided into 100 equal parts. So each bead is one of those equal parts. So how many equal parts made 1/10? Were equivalent to 1/10? 10 100ths. I have a 100 bead string here as well, and we can see, can't we, that 10 of the 100ths is equivalent to 1/10. Fantastic. So we can compare their relative sizes of values, can't we? And we can see again that 1/10 is 10 times the size of 100th. And 100th is 100th of the size of 1/10. But if we look at the whole of the bead string and we look at 1, then we can see that 1 is 10 times the size of 1/10, because we have 10 1/10ths. So 1/10 is a tenth of the size of 1. 1 has been divided into 10 equal parts. And here we can see with 100th, 100th is 100th of the size of 1. And 1 is 100 times the size of 100th. So it's really nice, isn't it, to look at the representation as a linear model as well. So we can really look at the comparative sizes of those fractions. Now that we're really confident about the size of 1/10 and 100th in comparison to 1, we can use this to help us compare fractions and decimals and convert between the different notations. And we use inequality symbols and equality symbols to help us do that, don't we? So it says here, can we fill in the missing symbol less than, greater than, or equals to? And I have 1/10 and 100th. And can you use the chart to help you? Can you visualise that? Pause me now and tell me if 1/10 is greater than, less than, or equal to 100th. How did you get on? What did you decide? Did you say that 1/10 is greater than 100? Fantastic. And we can see, can't we, that 1/10 was 10 times the size of 100th. So it's definitely greater than it. And 100th was a tenth of the size, wasn't it? So 100th is less than. But we said 1/10 is greater than 100th. And you might have been able to visualise that by seeing 1/10 and 100th and seeing that 1/10 is definitely greater than 100th. Do you think you can do this one on your own? We've got a mixture of fraction notation and decimal notation. Does that make it any harder? Should we still be able to compare them? I think we can, can't we? Pause me now and see if you can fill in the missing symbol. How did you get on? Did it help you to read the numbers first? Shall we do that together? So 1/10 is less than, greater than or equal to 1/100th. Excellent. So that's why it's really good practice to read it with its name showing its value. It doesn't matter if it's a decimal or a fraction then, does it? So 1/10 is greater than or less than 1/100th. Do you notice anything about this question? It's the same as the question on the last slide, isn't it? It's just that the notation was different. So we know that 1/10 is greater than 1/100th. 1/10 is 10 times the size of 1/100th because 1/100th is a tenth of the size of 1/10. So 1/10 is greater than 1/100th. Fantastic. You've worked really, really hard today, and I think you're all really super confident at being able to divide one into a number of equal parts and to be able to tell me which notation represents the number of equal parts that one has been divided into. So I'd like you to use the chart and use the representations that you have in your head. Think about the representations that we've used to compare these fractions and decimals. And can you explain why they're less than, greater than or equal to? So some missing symbol problems like the last questions we did. And also, it's time for a challenge. I'd like you to have a look and see if these statements are true or false. And again, you can use the chart to help you and think about whether a number is 10 times the size or a tenth of the size to help you answer these questions. So I've really enjoyed today. I really love looking at place value and digging really deep into the values of the digits. And I hope you do too. So enjoy your challenge. Take care. Bye.